Same. All right, I'm gonna work through every single problem on this review to make sure that you guys are ready to test tomorrow. Tomorrow. You didn't get one? Oh, well, you have all your work somewhere, right? Yeah. Okay. On this first page, it says calculate the following logarithms. You don't have to check your answer. All we're doing is calculating the value of each logarithm. On number one, log base 4 of 64. This logarithm is asking 4 to what power equals 64. So all you have to do is use trial and error and to find what exponent needs to be on 4 in order to get 64. You should get a value of 3. 4 to the third power is 64. On number 2, log base 3 of 1 over 243. This is asking 3 to what power equals 1 over 243. Okay, there's a couple different ways that you can use trial and error on this one. I'm going to show you those ways. Since we have a whole number that we're raising to an exponent and we end up with a fraction, that means that our exponent needs to be negative. So we can try different negative exponents like 3 to the negative 2 power. Change that to a fraction. That's not what we need. So then we try 3 to the negative 3 power. Change that to a fraction. Still not right. 3 to the negative 4 power. Change that to a fraction. That's not it. 3 to the negative 5. Change that to a fraction. We get 1 over 243. So our exponent needs to be negative 5. Okay, the other way that you can work this is by ignoring the fact that it's a fraction at all and just try different exponents on 3. Weird. Try different exponents on 3 until you get 243. So try 3 squared, 3 cubed, 3 to the 4th, 3 to the 5th gets us 243. So you know that the number that you need is 5, but since this 243 is actually in a fraction, 1 over 243, you just have to know that you have to make that 5 a negative 5. So whichever way that you want to do that is fine, as long as you get negative 5 for your answer. Does
that work for all of them that are in?
Yeah. Number 3, log base 10 of 10,000. This logarithm is asking 10 to what power equals 10,000. So you're just trying different exponents on 10 until you get 10,000. I wanted to show you guys something that happens because a lot of students had this issue. If you use too big of an exponent here, you end up with this e, which is basically just telling you that this is 1 times 10 to the 15th power. It's like scientific notation. All that means is that you're using an exponent that's too big. So try numbers smaller than 15. That's why I would suggest just starting with 2 and going up from there, because usually it's not too big of an exponent. So 10 squared and 10 cubed didn't work. 10 to the 4th gets you 10,000. So your exponent needs to be 4. Okay, number 4, log base 2 of 32 is asking 2 to what power equals 32. So you try different exponents on 2. You should get 2 to the 5th equals 32. So our answer is 5. Number 5, log base 3 of 1 over 81 is asking 3 to what power equals 1 over 81. So this is one of those where our exponent needs to be negative, but I'm going to ignore the fact that it's a fraction, and I'm just going to raise 3 to different exponents until I get 81. So it's not 3 squared, not 3 cubed. 3 to the 4th power gets us 81, but since it's 1 over 81, I know that I need to make that 4 a negative. So our answer is negative 4. Number 6, log base 8 of 2 is asking 8 to what power equals 2. So on this one, we have a whole number, we're raising it to a power, and we end up with a smaller whole number. Not a fraction, but a smaller whole number. That tells me that our exponent needs to be a fraction. So when you're trying different exponents, start with 1/2. 8 to the 1/2 power, that's not it. 8 to the 1/3 power, that gets us 2. So we know our exponent needs to be 1/3. If 1/3 didn't work, you would try 1/4, 1/5, and so on. Any questions on this first page? All right, let's look at the next section. On this next section, starting with number 7, all we're doing is converting between exponential and logarithmic form. So you're not solving anything, we're just changing between the two forms. So on number 7, we start with it in exponential form, which means we need to change it to log form. So to do that, if you want to use the loop trick, you start at the base, which is 9, and draw a counterclockwise loop. And since we're changing this to log form, the very first thing that we have to write is log, and then we can follow our loop. Base 9 of y equals x. On number 8, we're trying to change from log form to exponential form. So if you need to use the loop trick, you start at the base, which is x, and draw a counterclockwise loop. And since we're changing it out of log form, we're leaving off the log, and we just follow our loop. X to the z power equals y. Okay, you should be able to use that same method to get numbers 9 through 12. So number 9 should be log base b of 123 equals a. Number 10 should be 2 to the u power equals v. Number 11, we have log base x of 2 equals 3. And number 12, 2 to the w power equals m. Questions on this section? All right, starting with number 13, we're going to use the properties of logarithms to solve. Show all of your work and check your answers only if you find more than one value for the given variable. So if you just find one answer, you don't have to check it. But if you have x squared and you end up factoring and you have more than one answer, you have to check both of those answers. Okay, so on number 13, we have a logarithm that's set equal to a number. We can't just leave this logarithm off because there's not a logarithm on this side to match it. So instead, we're going to change this to exponential form. So if you need to use the loop trick, you start at 4 and draw a counterclockwise loop. You should get 4 squared equals 5x plus 1. So then we don't have an x squared term. We only have x. So all we're doing now is trying to get this x by itself. You're not trying to get everything to one side. The only time you would do that is if you had an x squared and you needed to factor. But since we don't have x squared, we don't have to factor, we just need to get x by itself. So let's go ahead and 4 squared is 16. Go ahead and change that. And then I want to get rid of this plus 1, so I'm going to subtract 1 from both sides. 16 minus 1 is 15. I'm going to move up here where I have more space. And these 1's cancel and leave us with 5x. Then since I want to get x by itself, it's being multiplied by 5. So to get rid of that, we divide both sides by 5. 15 divided by 5 is 3. I like to rewrite it where my variable comes first. You don't have to do that. But we get x equals 3. And since we only get one answer for x, we don't have to check it. I'm basically just doing that for time's sake to make sure that you guys have enough time to work all these problems on the test. Okay, on number 14, we do have a logarithm on both sides of the equal sign. And because both of those logarithms have a base of 7, that means whatever's here has to equal whatever's here. So to be able to solve for x, we're going to set those two things equal to each other. So 3x minus 1 equals 2x plus 3. Okay, so again, we don't have an x squared. We're not trying to get everything to one side and then factor. Instead, we want to get all of the x's to one side and everything else to the other side. It doesn't matter which one of these you move. I just like to think ahead and keep my x, to keep the coefficient on the x positive. So if I were to subtract 3x from both sides, that would give me a negative x over here. So instead, I'm going to subtract 2x from both sides. Again, it doesn't matter if you subtracted 3x first, you still should come out with the same answer. So 3x minus 2x is just x minus 1 equals 3. Okay, then I want to get this x by itself, so I want to add 1 to both sides to get rid of that minus 1. We get x equals 4. We don't have to check it because we only got one answer for x. So we just circle it and we're done. Questions on those two? All right. Number 15. Here's another one. It just has a logarithm on one side. There's not a logarithm on the other side to match it. So that tells me that we're going to have to change this to exponential form. So start at our base, which is 27, draw a counterclockwise loop. We get 27 to the 1/3 power equals x plus 4. There's not an x squared. I'm not going to have to factor, so I just need to solve for x. First of all, you can do 27 to the 1/3 power in your calculator. We get 3. So this is 3 equals x plus 4. Subtract 4 from both sides.
Oh, I get 9.
You probably did 27 times 1/3 instead of raising it to the power of 1/3. Okay, so again, I just like to write my variable first. So I'm going to write x equals -1. If you don't do that extra step, I'm not going to count off. It's fine. But since we only got one answer for x, we don't have to check it. Okay, number 16. We have two logarithms that are being added together. So we want to combine these into one logarithm. When we do that, the base stays the same, so it still is log base 2. And then we multiply x times x minus 6. Make sure that you've still written log base 2 here. You can't leave that off just yet. Okay, so it should still be log base 2. You're going to mess yourself up if you don't keep that on there for this step. Let's go ahead and multiply. So to do that, we just distribute this x. We get log base 2 of x squared minus 6x equals 4. Okay, now we have one logarithm on one side with just a number on the other. So we can't just leave this logarithm off. We have to change to exponential form instead. Start with your base, draw a counterclockwise loop. So we get 2 to the 4th power equals x squared minus 6x. If you left this logarithm off too early, you would end up with x squared minus 6x equals 4 instead of 2 to the 4th, and you would not be able to factor correctly. Okay, 2 to the 4th power is 16. And since we do have an x squared term and a term that's just x, that tells me we have to factor. So we do need to get everything on the same side. I'm going to subtract 16 from both sides. So we get x squared minus 6x minus 16. It doesn't matter which side you move it to. You just have to keep your x squared term positive. So since my x squared term was already positive, I know that's the side that I want everything to be on, which is why I subtracted the 16 from both sides instead of moving these two terms to the other side, because then that would make my x squared a negative x squared, and you can't factor unless it's a positive x squared. Okay, so now we're ready to factor. We factor into two sets of parentheses, and we know that x goes in the front of both of those. Then you're looking for two numbers that multiply to be 16 and add to be negative 6. So factors of 16 are 1 and 16, 2 and 8, 4 and 4. Yeah, looks like 2 and 8 are what I'm going to have to use. And I know that one of them needs to be negative because when they get multiplied together, they have to give us negative 16. So I want to look at my middle term to see which number needs to be negative. If this middle term is negative, then your bigger factor needs to be negative, which means our 8 would be negative. So x minus 8, x plus 2. If this middle sign were positive, that would mean our bigger factor would need to be positive.
Multiply equal to 16, add equal.
Yeah. Okay, now that we have our two factors, we set each factor equal to 0 separately. I'm going to move up here where I have more room. So x minus 8 equals 0, and x plus 2 equals 0. Solve both of these for x. I'm going to add 8 to both sides to get x equals 8. Subtract 2 from both sides to get x equals negative 2. Now we have to check because we got more than one answer for x. So we need to plug both of these numbers back into the very first line of our problem, this line that we were given. That's also very important. You can't skip down to here and plug in, you have to plug into the very first line of the problem. So if we check x equals 8, we're plugging in 8 for x. Log base 2 of 8 plus log base 2 of 8 minus 6 equals 4. We want to do any math that there might be to make sure that we don't have a negative where we're not allowed to have a negative. So log base 2 of 8 plus log base 2, 8 minus 6 is a positive 2. So there's not any negatives where there's not supposed to be negatives. From here, we can follow the same steps that we followed when we were solving. So we want to combine these two logarithms into one. Log base 2 stays the same, and then we're multiplying 8 times 2 equals 4. The next thing we did was actually multiply, which when we were solving, we had to distribute this x right here. All we have to do is multiply these two numbers together. So we get log base 2 of 16 equals 4. Change this to exponential form to get 2 to the 4th equals 16. You can do 2 to the 4th in your calculator. It's 16. And 16 equals 16. That's a true statement. So we can go back and circle x equals 8 because we checked it and it worked. We know that x equals 8 is a solution. Okay, so let's check -2. Remember, go all the way back to the first line. Log base 2 of -2 plus log base 2 of -2 minus 6 equals 4. Okay, so right off the bat, we have a negative where we're not allowed to have a negative. It's not being squared, so it's not going to become positive. It's going to stay a -2. And if we wanted to, we could look at this part right here. -2 minus 6 is going to be a -8 as well. But even if just one or the other was negative, we would still not be able to move on. So x equals -2 is not a solution. This is why it's important to go back to the very beginning, because if you were to skip to, say, this step and just plug in your -2 right here, this inside the parentheses would end up being positive. And you could go on and say that x equals -2 is a solution because you didn't start back at the first line. So make sure you're going back to the very beginning. Questions on that one? All right, let's do 17. On number 17, we have two logarithms that are being subtracted. So we're going to combine those into one logarithm. Log base 3 stays the same. And since the logarithms are being subtracted, this time we divide. 126 divided by 9. Equals log base 3 of x. Okay, now we have a logarithm on both sides of the equal sign. Both of those logarithms have the same base. So we know that 126 over 9 has to be equal to x. So we're just going to set those equal. 126 over 9 equals x. Okay, so then all we have to do to find the value of x is find what 126 over 9 is. You can do that in your calculator and you get 14. So x equals 14. We don't have to check it because we've only got one value for x. And we're done. Any questions over this page or anything on the study guide? Okay, your test tomorrow will be formatted exactly like this review. The questions will not be exactly the same, but they will be similar. So there's going to be 17 problems. If you want to listen to music, make sure you bring headphones and that you have a playlist that you're going to be happy with. Because once you start your music, you have to put your phone away, and I can't see it out again during the test. Make sure you bring your Chromebook so that you have a calculator to use. Or if you have a calculator, you can bring a calculator. But you can use your Chromebook for the calculator app that we downloaded. Those of you on Zoom, you will need to have a space kind of set up where I can see all of you from your head to your hands. Both of your hands have to be in the screen the whole time. You can have your Chromebook pulled up to view the test, obviously, and you can have your calculator app pulled up. Other than that, you shouldn't have any tabs open. Nothing should be up on your Chromebook. I'll have GoGuardian running so that I can see what you're doing on your Chromebook. And if I see your phone in the screen at all, that will also be an issue. So make sure that you're prepared and have everything ready for that. If you want to come to campus tomorrow to take the test, if you think that will be less stressful for you, then go for it. I think that's really all. Make sure that you spend time studying, especially if you didn't understand something on the review. Make sure that you go over it and you're prepared for the test tomorrow.